Welcome to the Road to Zero podcast. I'm your host, Nick LeBlanc, founder of Network Potential Consulting. We're here to explore the fast emerging zero impact economy, which is transforming the way we do business, bringing prosperity and regenerating the natural world in the process. And I invite you to look at how you can position your business at the forefront of this global movement. Today on the Road to Zero, we're talking to Rob Bernhardt, an expert and consultant in energy efficiency and policy, who's joining us from Victoria. Welcome, Rob, and thank you for being with us.
Thank you, Nick. It's a pleasure to be here. Thank you for having me.
And now, as a past CEO of Passive House Canada and a builder and developer of Passive House yourself in a previous life, can you tell us how you got interested in this type of construction and this whole idea of energy efficiency? What was your pathway to this?
Well, Nick, I've had a lifelong interest in sustainability and the environment, but I started out practicing law for over 20 years. I transitioned from that into international competition, venue design, construction, delivering competitions up to the Olympic level. And so when the 2010 Olympics ended in Canada, after that, we moved to the Victoria area and looking for a home to build, scanning around at sort of what type of home to build, what sort of standards to adhere to. The Passive House standard made a lot of sense. One hadn't been built on Vancouver Island, so we decided to do that just because it made so much sense. And in the course of building it, we thought, this does make a lot of sense. It's not that hard. It's not that expensive. People will buy this. So we decided that we would start developing them, building them and selling them. So we developed the first Passive House strata, small multi-unit buildings in Canada, and they were in the Greater Victoria area as well. And then from there was an interest. These were early years. There was an interest in establishing a building standard association for that level of construction in Canada. I understand organizations, how to develop them. So I agreed to be the initial CEO of that organization and launch that organization. So did that. And I stepped down from that role almost 2 years ago now. So I've been engaged in other activities since then, but continue with my interest in really what I call people and climate friendly buildings.
And can you tell us a little bit about what was so interesting and special about the Passive House process in itself? Like, what does it provide, or can you give us a quick, for maybe people who haven't heard about it before, what is Passive House?
Well, Passive House is known as a building energy efficiency standard. It is the most stringent such standard in the world by a large margin. There's no other building standard that comes close to that. And the magic of it, what appealed to us, was that the outcomes that the building delivers in operation are about what you would expect when you're designing it. There's not what's commonly called the performance gap in the industry, where there's fond expectations of how a building will perform, followed by performance that doesn't match those expectations. So we like that. We also liked its just basic building science approach, and that it wasn't prescriptive. It was a process for delivering an outcome in buildings and enabling designers and builders to achieve those outcomes in whatever way worked best. So that's really what appealed to us. And with the efficiency comes all kinds of other benefits. Because high quality ventilation is required, there's extremely good air quality. There's a constant supply of filtered fresh air. The thermal comfort in the building is beyond anything we had experienced before. With the even temperatures throughout, there's no condensation, mold, or mildew on the inside surfaces because the inside surfaces are warm. That sort of thing. So it all just made a lot of sense. And when all of those qualities can be delivered affordably, we just thought that was a compelling reason to build to that standard.
Yeah, I remember actually back in several years ago, I did one of those Passive House design courses. And what I really love is even the whole design question is, how do you design it so it doesn't need a heating system, or it can be heated by so little? And that really was like, wow, that's such a different way of approaching it.
Yeah. Yeah. It's about making this highly efficient building. We don't say no heating system, but the heating systems are small and they're simple. And because the thermal envelope is such a high quality, you typically, for example, may not need heat in the bedrooms, that you keep it warmer where you want it warmer, warm up the bathroom floors, put a little heater in the living area, and the ventilation will move the warmth without moving the air, but move the warmth from one room to the other, because the heat is exchanged with the incoming air. So the air being supplied to places like bedrooms comes in at a comfortable temperature.
Yeah, and that comfort piece, I'm really amazed at what you get as a, if you will, a byproduct of trying to create something that's really energy efficient. Because I've heard, on a busy street corner, for instance, you wouldn't even hear the traffic because of the triple pane windows and the thick walls and the lack of drafts and really how comfortable the buildings are because of that.
Yeah, the thermal comfort is remarkable. We had read about it; it was intriguing to us, but when you've never experienced it, it's difficult to conceive of. And just how you can sit beside a large window in the winter and not feel that chill. Your warm skin radiates heat to the cold surface of the window typically. But if the inside surface of the window is warm, then you don't feel that chill that you get from your body radiating heat to the window. And so that's part of the building science behind Passive House, that the inside surface temperature of the windows, for example, is to be within so many degrees of room temperature in winter conditions. So it's this sort of even warmth. Your feet stay warm, your bare shoulders stay warm if you're sitting by the window, that sort of thing. It's quite remarkable, and it actually affects how you choose to live in the house. But the flip side of it is for the summer too, because you need to design for year-round comfort. So they're designed, or should be designed, to be cool in the summer as well. You keep the summer sun off the windows. You have some way to protect them from the summer sun. And that thermal envelope keeps it cool. If you cool it off overnight, say if you're in a single family home and you have cool nights, you can cool the place off overnight and keep it cool through the day without any mechanical cooling. Typically in bigger buildings, or maybe in climates where it's warm through the night, you'll need some mechanical cooling, but the amount of mechanical cooling you need is vastly reduced.
Yeah, I love the beautiful solution of putting that design front end work and coming out with something so eloquent that works so well by this design without needing all this extra, like you said, equipment and machines. And can you give us an idea, performance wise, like how much less energy does a passive building use compared to its counterpart, let's say non-passive design?
Well, it's typically up to 90% less heating and cooling energy than a conventional building. So it's not designed to be zero, but it's designed to be a very small amount. So the building is inherently stable. It's resilient when it's that efficient, in that if the heat system goes off, the power goes off, the building remains habitable just because of how it's designed.
It's a really interesting point, and especially what we've been seeing here with, the heavy rains just here in BC, when you can get cut off, your power gets cut off, and having a building that really doesn't lose that much heat, or you could heat it fairly easily is quite important in the issues we're facing these days and the conversations we're having.
Oh, sure. And we've, after building our home, we put some photovoltaic panels on the roof. We haven't bothered putting a battery in just because we happen to be in a place where the grid is very reliable. But if we had a somewhat less reliable grid, we'd put a battery in. And because the building is efficient, one battery would power the house for days. And if it isn't the dead of winter, dark winter sort of thing, we wouldn't have to change our lifestyle at all, because the photovoltaic panels would keep recharging the battery. I mean, for a good part of the year, we're generating as much energy or more than the home uses. It's only in the shortest, the shortest days of the year that we don't.
Yeah, very impressive. And can you give us an idea of how many buildings have been built? Like where we are today in, imagine the Canadian market best. Like how many projects are out there, or how many buildings are out there, and how much are you seeing happening in that space?
Oh, it's vastly different than when we started. The growth has been really quite rewarding to see. Globally, there's tens of thousands of projects. I can't keep track of them in Canada. I used to sort of know the projects in Canada when I started. There's just no way. I can't keep track of the projects in there around my home region anymore. And I keep sort of running across new ones that I didn't know about. So, and there's individual practitioners, architects, engineers, contractors in Canada now who count their portfolio of passive house projects in the millions of square feet. They've done over 1 million square feet of projects. So, they're across the country. They're becoming more and more common. Our building codes are still a long ways from delivering this level of performance, but it is this level of performance that's been identified as the level of energy efficiency that buildings will have to deliver to effectively mitigate climate change. Right? There's the four things buildings need to do, the four fundamentals to mitigate climate change. Number one, we've got to minimize the amount of operating energy they need, and that means to make them at least as good as passive house performance. Number two, they need to be powered by renewable energy, no more fossil fuels and other dirty sources of fuel. Number three, we need to minimize embodied carbon. And the fourth thing is we have to do the first three as rapidly as possible. And every time we do sort of half measures, it locks in emissions, it locks in energy loads for decades because buildings have a very long life cycle. We only build or retrofit them in a time scale of decades, not in the shorter term. So these half measures are really very detrimental to the achievement of climate goals.
Yeah, it's a really interesting point too, and I guess the other piece of that too is the risk of not implementing that in any new construction, and then because of a higher carbon tax or even legislations, you might be forced to do a retrofit way earlier than you'd want to, just to be able to continue making the building economically viable. So that's a kind of a current risk that we're actually seeing now, I imagine.
It is, and also as more and more buildings become better buildings, then the ones that are built sort of to the current code become less and less valuable. There's stated plans, certainly in Canada and many jurisdictions, to implement a building benchmarking and labeling program where there'll be a label put on the building to say how efficient it is. And when that is done, at least when it's done properly, that impacts the market value. So if building owners want to maintain their value, their rental value, their sale value, whatever it is, it's really important that they offer these better buildings. And it's still legal to build the code, but I would say that it's a poor financial decision, particularly
Yeah.
given how affordable it is to do much, much better.
And that's a good point. What would you say is the difference between building a regular construction to something at a passive standard? And there's a couple of things to look at. There's the long-term cost or even the immediate cost. What does that look like right now? Because now we've got a bit of a market for it. So some of these triple pane windows are easier to buy than they probably were when you started.
Oh yeah, we thought we'd have to import them when we built our house, and as we were finishing the design, a local manufacturer emerged, and we were thrilled to be able to buy them from the one manufacturer there was in the country. So that was progress then, and I'm not sure how many there are just in our province now, but certainly the selection is way up. And mechanical equipment that works as well as sort of passive house quality ventilation and other mechanical equipment is now being produced domestically as well. But the costs have come down. There's often a learning curve with designers because these buildings have to be designed differently so that they're inherently efficient. And it isn't a matter of adding stuff to a conventional design, that's not how real efficiency is achieved. And that's what most people tend to think. They think, well, we have to put on those better walls, expensive windows, really good ventilation. That's going to cost a bundle. But that's not how these buildings are done. And they're actually designed differently. They're inherently simpler. And there's a number of offsetting factors that drive down costs. So sure, the windows are likely to be more money, although the price bump on windows is much less than it was, and it keeps coming down. And also codes are coming up too, so the gap gets to be a little bit smaller. Triple pane windows are now pretty common. They weren't when we built our house. They're maybe not very good triple pane windows, but they're triple pane. And so the experience around the world is that the costs of these buildings, passive house or higher performance, are in the range of conventional buildings. Once a designer or a builder has a bit of experience with this, they figure out how it's done. And maybe there's a small bump of a few percentage points, but there's plenty of examples where they've actually cost less. There's probably more examples where they cost more, but there are many, many cost drivers for buildings that have absolutely nothing to do with efficiency. And those other factors have a much greater impact on cost than the efficiency measures do. And even on the small scale of a home, if you're paying more for windows, you're paying less for a heating system. There's some of that sort of set off too. But something else that falls on design, and this is particularly important for smaller buildings, is that one of the best ways to make a building efficient is to give it a compact form. And many designers have sort of fallen into the habit in designing buildings now of having what they call an articulated facade, and lots of bumps, jigs and jags in the walls. And that goes down into the foundation, often into the roof line. And that's how they create their artistic or architectural interest sort of thing. What that does is dramatically increases the wall area. So if you look at the scale of a home, a home that's in the shape of a cube, if that's say called 100%, a lot of the homes that are supposed to be affordable, cheaply built spec homes, track homes, they'll have 50, 60% greater envelope area than that cube. And that's the most expensive part of the building. You're paying for that by the foot. It's a huge increase. So if that home were designed to be efficient, and maybe you bring the envelope area down to, 110%, 120% of a cube. It's not a cube, but it's more compact. That building, that home, as a passive house, can be cheaper to build than what is considered to be a cheap spec home in a subdivision next door. So there's all of these sort of factors that go into the mix. And the end result is the practitioners that are doing this, that know how to do it, are actually delivering these buildings really affordably. And the owners then get to pocket all the benefits I spoke about earlier, in terms of comfort and hygiene and health and so on. But they also save dramatically on operating costs. It's not just the energy costs they save, but these buildings tend to be simpler, and the equipment is better quality. The windows are better quality. They last longer. The ventilation equipment is high quality. It lasts. So the maintenance is less.
Yeah, it's a new design paradigm, and especially factoring 90% decrease in heating costs. That's substantial over the long run, for sure.
Oh, it is. And it enabled us, even in the early years when we were developing and selling these projects, when we sold them for a premium, because there's enough buyers around who recognize what they're getting and will pay a premium, it was still more affordable for the buyers than a conventional condominium would have been. If the price was higher, but if they added that increase to their mortgage, their operating costs went down by more than the mortgage went up. So it's not just the the energy costs they save, but the maintenance costs and so on, as I was saying, the strata fees can be much lower than they would otherwise be. So, so the affordability was there even in the early days, and that affordability continues to improve as the market develops.
Okay, and then now we're talking definitely going beyond just you can definitely do a single family passive home. What are some of the bigger projects? Like how evolved has this become now? Because I think there's some fairly big projects even in Canada, let alone the world. But what are some of the bigger projects, more groundbreaking projects you're seeing that using the standard?
Well, there's one project in China that's certified passive house. I think it's 1.2 million square meters. That makes it what, a 13, 15 million square feet, one project. It's a series of high-rise towers and other things all built as one project. I'm out of date here. Last time I checked, the city of Vancouver, I thought had 5 high-rise passive house projects going. There's lots of MURBs, a lot of affordable housing. Like affordable housing agencies recognize the long-term value and affordability of these projects, so they've really been putting a lot of the multi-unit buildings in place of any scale, a few hundred units down to just a few units. There's a student residence going up within walking distance of my home here at the University of Victoria. It's over 700 beds, a huge commercial kitchen that dishes out, I don't know, 5 or 10,000 meals per day. It's designed for that. Big volume kitchen at any rate. I'm not sure of the volume. But there's a really attractively designed rec center at Clayton Heights in Surrey, BC. There's a great variety of projects across the country. The Toronto Community Housing is working on a very large retrofit project. They operate over 2,000 buildings, most of which need deep energy retrofit. So they're looking at scaling up retrofits to the passive house level. There's a retrofit standard within the building standard called Interfit, and they're targeting those sorts of outcomes. So it's both in the existing buildings and in the new buildings. You're seeing quite a bit of it. The City of Hamilton, City Housing Hamilton, just completed, or they're virtually completed, a deep energy retrofit to the Interfit standard of a tower, affordable housing tower in Hamilton. So yeah, it's quite. There's hospitals done. There's a major hospital in Frankfurt that was completed. I think it's now operating, but it's very nearly completed if it's not operating. So if these large scale projects, hospitals, swimming pools, museums, if they can be done, I think almost anybody can be confident that almost any project can be done in any location.
So it sounds like the market's squarely growing. So they're not forced to build to this standard, but it sounds like a lot of people are going down this route because of economics, better product, and less maintenance. So quite a few business reasons to do so. And where do you see it going in the future? Do you see the regulatory level leading towards this? Do you see this continuing to expand as it is? What's the future for passive house?
Well, at the moment, despite the growth, it still remains a relatively small part of the market. The drive to build the worst building that it's legal to build, that you can possibly build, that drive is very strong. And nobody likes to change. You know, they've got a business model, they have a way of designing, a way of building. People want to keep doing what they've been doing. So until regulations change, personally, I don't see these better, resilient, healthy buildings becoming the mainstream, because typically mainstream buildings follow the least that you're allowed to do by law. So if you can imagine in the restaurant business and bringing out a meal and somebody complains about it, you say, well, it's legal. But that seems to be the way it works in construction. If it's legal, then it's good enough. And so building codes, if we're going to have building codes, if we're going to mitigate climate change and also adapt to it, provide the resiliency, et cetera, then buildings are going to have to perform at this level for energy efficiency. We're going to have to switch to renewable energy, and we have to minimize embodied carbon. We've got to do all of those things. It isn't effective to try and do one or two of those things. They all need to be done. They're all critical. So Passive House addresses the energy efficiency, and it works really well with renewable energy. A lot of the practitioners who are doing Passive House buildings are also very tuned into embodied carbon, and there's greater and greater interest in doing that. There's tools that enable you to do that effectively. So if the regulators are going to do what they have agreed to do under international agreements, then yes, they're going to do this because this is what's required. And the International Energy Agency, the UN, the IPCC, all of these agencies have been pretty clear. And I've had some involvement in developing some of those global norms. But so that's the level of performance we need to come up to. At the moment, the regulators are really, really struggling to do that. And certainly in Canada, we're not yet making much progress.
We've seen the step code in BC is maybe one way towards that. And I know the city of Vancouver itself, not necessarily the provincial building regulator, but they're actually are wanting to create a pathway towards not necessarily a passive house, but at least higher efficiency buildings. Does that give you a bit of hope, or do you see some promising movements in some of those initiatives?
Yeah, the city of Vancouver is unique in that they have their own building code. They're the only city in the country that does. So they're able to sort of lead in this way. And they've been very strong advocates for passive house development, and they've incentivized it and so on. And that's certainly the direction that their building standards have been headed as they transition the market to that. The BC Step Code was initiated with that thought in mind. I think, as I was saying earlier, people don't like to change. Change is hard. Inertia is a powerful force, and the forces of inertia go to work, and the plans get watered down. And there's now good data to show that the BC Energy Step Code will not achieve its stated objectives as it's currently drafted. It could be improved. The concept is an excellent concept. It's one I was involved in developing, and we supported it at the time. But decisions get made over time to accommodate different interests, accommodate different voices, and we're dealing with the laws of physics here. So we don't get to negotiate the laws of physics.
Definitely. Now, for some listeners who want to push the economy in that position, what's the best thing to do if someone was looking to rent a home, build a home, or even commercial developers looking for space? What would you suggest they do to be able to further this, or even get themselves in a high efficiency building or structure?
Talk to somebody that knows how to do it. And if you are getting advice from someone that says it's too expensive, it doesn't work, it's too hard, can't be done, whatever, then you're talking to someone that either doesn't know how it's done or doesn't want to do it, or both. Talk to people who are doing it. There's thousands of people doing it. It simply isn't tenable to say it can't be done or it's too expensive. So when you hear that perspective, you're talking to someone who doesn't understand how it's done. And so if people would like this outcome, I would recommend two things. Number one, if you want a building yourself that is like that, then connect with the people that are doing that. But secondly, if you want these buildings to be the norm, let your elected representatives know that. Write letters. They matter. Speak up. And buildings are responsible for roughly, ballpark a third of our emissions, energy use, that sort of thing. The stats vary a bit by year and location and so on, but they're big enough that we cannot address climate change without addressing buildings. So it's really essential that we take this issue seriously. And I would certainly urge all listeners to engage with their elected representatives, their local government, their state or provincial government, regional government, and their national government at all levels, and let them know that this is important and this influences voting intentions.
Well, thank you for sharing us and guiding us through this conversation. And it's really, I can't wait to see the day when that becomes the standard, because I think we'll be living in an amazing place.
Well, the buildings will certainly be more comfortable and better to be in. So, but Nick, it was a pleasure to be here and have the opportunity to speak with you again. So, good luck with the endeavors that you're taking on as well.
Well, thank you, and I look forward to seeing what your next project provides.
Thank you. Bye now.
Thank you for joining us today. Check us out at www.futureproof-network.com to hear our other episodes, links to our YouTube channel, and to join our Future Proof Business Network. See you again in our next episode.